Good evening. I am Pranavi from CSCE section. Today I am going to present a PPT on the topic logic gates. So let's start. First of all, what is a logic gate? It is a hardware implementing a Boolean function which performs a logical operation or one or more inputs and only produces a single output. When logic gates were started implementation, they implemented first on diodes and the transistors, uh, and also slowly it has been using in the construction of vacuum tubes, electronic relays, fluid logic, pneumatic logic, and etc. When logic gates are being amplified, uh, then the all the algorithm and the mathematics can be described with using the Boolean logic. So next slide. There are three logic operators, and, or, and not gates. First, let's see one by one briefly. First is the NAND gate. AND gate, it gives the true output. If the output is 1, the all the inputs will be true. And for representing the dot is used for the representing the AND operation, and this is the symbol of AND gate. Next is the OR gate. When the output is 1, if one or more inputs are true, and the plus gate is used to show the OR operation, and this is the symbol of the OR gate. Next, NOT gate. NOT gate, it is the electronic circuit which it gives the inverted version of the input at its output, and it is also known as an inverter. If uh, if the input variable is A, it is known as not A, and it can be also shown as A dash or A bar. Next. Next is the NAND gate. It is a combination of NOT and AND gate, which is equal to the NOT gate. And if the outputs of all the NAND gates are true if the inputs are false. The symbol of AND gate is a small circle on the output. The small circle always represents the inversion. Here we can see the AND operation and NAND symbol. Next is the NOR gate. It is a combination of NOT and OR gate, which is equal to the OR gate and followed by the NOT gate. And all the NOR gates outputs are false if the inputs are true. And the same way as the NAND, it has a small circle on its output and it represents the inversion. Next, XOR gate, that is exclusive OR gate. It gives the true output either the if both the inputs are true or not. If both the inputs are false, it gives the true output. And the symbol is encircle plus. Uh, this is used to represent the OR XOR operation, and this is the symbol of the XOR gate. Next is the XNOR, that is the exclusive NOR gate, which is the opposite of the NOR gate. It gives the false output if the both inputs are true, or if both the inputs are false. When the XOR gate is same, represented with the small circle on the outputs, and the small circle as usual represents the inversion. Next, this is a table of the truth tables and the algebraic functions and the symbol of the gates. This is the symbols of the gates, and this is the algebraic function, and these are the truth tables. Next, there are some applications of logic gates, like it has been a building block of all the digital circuits and the devices which are being used right now. Next, there are some digital devices that logic gates are used, like computers, microprocessors, microcontrollers, digital and smartwatches, smartphones, and etc. Next, there are some as logic gates have some pros and cons. So let's see the advantages first. It carries out the basic functions very easily, and the speed is extremely high, and its high rate speed makes this uh, future very useful, and its reliability, scalability, and its low cost and low power consumption, as it has a very low cost, making the production viewpoint is very less and making it crash in the market. And next is the low power consumption. It consumes very low power, hence very less energy is needed for this logic gates. Next, and the disadvantages of logic gates are its complexity, its propagation delay, and its noise sensitivity and power dissipation. Thank you.